Space colonisation, the next step for mankind. One of these days we're going to use all the resources on our planet, or we will create so much waste that we'll want to move out, or we will overpopulate the planet, or global warming will happen. Either way, we are eventually going to move to Mars. But the question is, what are we going to need on Mars?
Food,
Yep,
water,
yep,
shelter.
yep. But one of the most important things we're going to need is electricity. Now before we talk about electricity, let's examine some of the things we're going to need to power. Since Mars has an atmosphere that's a lot thinner than Earth, it doesn't hold on to as much energy. Combining this with Mars being further away from the Sun, it gets really cold at night, with it being about 20 degrees in the middle of the day at the equator and an average of minus 60 degrees at night. Now this basically means that we are going to need heating, which is going to take electricity. Okay, so we got heating. What else do we need?
Food!
No.
Please?
No.
This video sucks.
Do you want to go home? We need lights. We won't be able to see at night if we don't have lights. We also need to be able to communicate back to Earth, as well as many other luxuries. So we've basically established that we need electricity to be able to do stuff on Mars. But how do we get that electricity? Now we're going to talk about the most effective forms of power generation here. So no large lands of crops producing biofuel or monkey-powered pedal bikes. There are some obvious power generation methods, so let's get this one out of the way. Hydropower. As many people know, scientists are constantly battling to prove that there is water on Mars. But if there is some unknown underwater caves and rivers, we can create and use hydropower. Similar to the dams that we have here on Earth, we may be able to set up underground dams on Mars. This will unlikely happen as we would have to dig large holes underground to create these dams, but it is an option. Next up, wind power. The winds on Earth are pretty good for wind turbines. On Mars, not so much. As the atmosphere on Mars is about 100 times thinner than that of Earth's, it would take a really strong wind to move a turbine. Think force equals mass times acceleration, where force is the force applied to the turbine, the acceleration is the speed of the wind, and the mass is the amount of air the wind is moving. With thinner air, there is less mass, which means that a greater speed of air is needed to spin the turbine. Although, we have some fixes for this. As Mars's gravity is less than ours, we would be able to create larger turbines with larger blades, which can better harness the winds on Mars. But this still doesn't help with the dust problem. As the winds increase on Mars, they pick up tiny pieces of loose dust particles from the surface and throw them into the air. These dust particles can wear away at the turbines, creating maintenance issues, but this can hopefully be overcome with good engineering. Now, a more reasonable energy option. Aerothermal. Now aerothermal means the same as geothermal, as the geo prefix, which refers to Earth, is replaced with the aero prefix, which refers to Mars. It is not 100% known if Mars contains hyperthermal zones in the crust, but if it does, it would be a highly reliable, safe and continuous source of energy. If these spots are found, they would more than likely be the first places to be colonised. Take this image of a geothermal power plant. It would work the same way on Mars. Water is pumped down into the hyperthermal layers of the planet. The water is then heated and turned to steam, which rises up to the surface, which spins a turbine to generate electricity. Simple, safe, reliable, and effective. Now, on to something more scary. Nuclear fission. Nuclear fission works by a process where an atom is split into two smaller atoms. This splitting of atoms creates large amounts of energy. I'm sure we have all heard of the problems that arise when making nuclear power. This is why we are going to use liquid fluoride thorium reactors. Now you may ask, what's so good about this type of reactor? Well, I'm going to tell you. It doesn't use water, so we can't have high pressure steam explosions. The fuel can't have a nuclear meltdown. It produces little waste that doesn't need to sit around for millions of years. And we have already built one and it's been working perfectly fine. Now you may be saying, what's wrong with it? The real answer to that is there really isn't anything wrong with it. This reactor converts thorium into uranium, which can then go into nuclear fission. and thorium is highly abundant on both Earth and Mars, therefore it is cheap and would be a good fit for Mars. As the reactor uses liquid fuel, it is able to use most of it up, meaning that we won't need large cooling and storage areas for the radioactive waste. Did I mention that these power plants don't rely on wind or a sunny day to work? Nah, didn't think so. As our technology keeps getting better, nuclear energy will continue to grow as a viable generation method, producing mostly clean, reliable and cost-effective energy to power large Mars colonies. Now the easy and most important one, solar power. Solar power will be the simplest, short-term way of producing power on Mars. And we know it works as we have already used solar-powered rovers to explore the planet. So we understand a solar panel on Mars would produce about half the electricity that it would on Earth, as Mars is further away from the Sun than Earth is. This is hardly a problem though, as the price of solar panels are continuously decreasing and we are always coming up with bigger and better panels. Solar power is a highly sustainable source of power. That sun isn't going anywhere. For our Mars colonisation, we would be able to build large rolls of solar film on Earth and send them off to Mars. We could then easily roll out these films and create large fields of solar arrays, making them easy to put up to have fast and effective energy. There is only one major problem with these solar panels, besides nighttime: dust. Dust in the air can land on the panels and block them from working, which eventually cause the death of the Mars land rovers. However, this can be easily fixed with a wipe down from a person or by some strong winds. The only other problem is that we would need to develop ways of storing this energy for the night, but inventions like the Tesla home wall battery could help with this. So we have gone over that moving to Mars is going to require electricity, especially for things like heating, lighting and communication. We have gone over the various power generation methods Mars has to offer, such as solar, wind, nuclear, hydro and aerothermal. And that's about it, colonising Mars and the energy methods used to do so. We will get there one day. Thanks for watching.